Hi everyone. So in this question, I'm going to show you how to solve a temperature related problem using the idea of a linear relationship. And we do know that any physical property of a body that varies linearly with temperature can serve as a measure of temperature itself. So in this question here, we are given that in a constant volume gas thermometer, the gas pressure at 0 degrees Celsius is 200 mmHg. So the first line itself already tell you that we're going to use gas pressure to measure temperature. So the physical property of the body in this question itself is actually the gas pressure. And since the physical property varies linearly, so we can assume that the gas pressure varies linearly with temperature. So gas pressure in this context will serve as a measure of temperature. Now, since we know it's linear relationship, so we know that when we are to sketch the graph, it's going to be a straight line graph. So first things first, sketch the axis, gas pressure versus temperature. Gas pressure 200 mmHg, temperature 0 degrees Celsius. Gas pressure 270 mmHg, temperature 100 degrees Celsius. So sketch out these two coordinates first. And I say again, since it's a linear relationship, what we can do is to draw a straight line cutting through these two coordinates because we're going to assume a linear relationship. And we have to calculate the room temperature when the gas pressure in the room is 200 mmHg. So 220 mmHg is between 200 and 270. So that puts the temperature in between 0 and 100 degrees Celsius. So you just place 220 somewhere in between 200 and 270. Never mind if it's not accurate. We are not going to mark for accuracy, so not to worry about this. So once you put 220 somewhere in between 200 and 270, by drawing a dotted line across to the graph, you'll find that your theta lies between 0 and 100 degrees Celsius. And we're going to label these three coordinates A, B, and C. And go back to the very basics. Gradient AC equals gradient AB. And gradient AC will be P100 minus P0 over 100 minus 0 equals P theta minus P0 over theta minus 0. And this is where P100 is the gas pressure when temperature is 100 degrees Celsius. P0 is the gas pressure when the temperature is 0 degrees Celsius. And P theta is the gas pressure when the temperature is at theta. And substitute in the values, you get 270 minus 200 over 100 minus 0 equals 220 minus 200 over theta minus 0. Now from this point on, I'm not going to dwell too much on it. This is not a math lesson, it's a physics lecture. By simple mathematical manipulation, you're going to get theta equals 28.57 degrees Celsius. Yes, we try to express it in three significant figures. So make it a habit that when you have any answers with more than three significant figures, always express 4SF or more first. Then finally express in 3SF, which is 28.6 degrees Celsius. Why express as 4SF or more first? Because you do not know when you need that value. So just make it a habit.